So here we are, and are you still able to see my screen?
Yes, sir.
Okay. Are you able to see my slides as well?
Yes, sir.
Excellent. So we were on the slide unit testing, and unit testing, if I can ask a few questions in between as well. Who would do the unit testing? Obviously, unit testing is the process of testing individual components in isolation. That means either you are testing a small method, uh, a small piece of program, you mean? You could be testing a small module, in a typical structural programming. If you are doing object-oriented programming, you will be testing a class. And sometimes you will be testing a component. Now, when we say component normally is also a class, but a component can be a combination of classes as well, which works in tandem. So the unit of testing normally in object-oriented programming paradigm is a class, or an object. So what is the difference between class and object? Class is the blueprint which contains all the representation of the entity that it represents. Like a class could be a banking customer. A class could be say for example, a monitoring agent which monitors weather data. Say for example, it could be inventory class which contains your inventory details. It could be anything which represents the real world entities in your business. And obviously the object is the instantiated form of that class, which has a certain attribute in general, which is represented as data type in that class. And it has a certain behavior, which is represented by different functions or methods that you have coded in your class, and you have programmed them to do certain activities. So this is essentially what we are doing. So unit testing is basically the smallest or the first step of testing your application. And the question is, who does this unit testing? Who does the unit testing? Hello? Anybody can answer? Is it the developer who does the unit testing? Is it the specialist testing engineer who does the unit testing? Or is it the client or the customer who does the unit testing?
Pardon me, sir. I think from my perspective, when the developer is coding, they perform a unit testing as well from the IDE, and it can be external testers as well to verify the code and the functions of their program, and because it isn't the functionality of their program as well when the unit testing. So it could be either or.
Right. In fact, the correct answer would be that the developer does the unit testing. As they are developing their modules or their classes, they will do the unit testing. So they will run the unit test on their side. External tester, whether it is a testing engineer or what you call that ITG, independent testing group uh, person, expert, would actually come and do mostly a black box testing. They won't really get into your code. They won't really go and analyze your functions and methods thoroughly. They normally don't do that. So there, on the other hand, there can be some organizations who have a specific independent department of testers who would just go and analyze a particular code. Probably there could still be some specialists who are designated as testers, and they will do the what do you call that static testing or the white box testing. It wouldn't be an independent engineer normally, But yes, it depends from organization to organization. So the classical answer here is going to be that the developer does the unit testing. But yes, I can agree to some extent in certain organizations, if they are really uh, much concerned about the quality, and they really want to, they don't trust their developers too much, they may have a dedicated tester also allocated for doing certain unit tests. They may not exactly run the unit test, because unit test is simply like giving a piece of data, creating a test case and running it, piece by piece. But they may actually go and analyze your code to see whether you have followed the good programming practice, which is established for a particular technology or a particular language, programming language. They might test, also they might create specialized test cases for the boundary cases, as we discussed about that earlier. So there could be a possibility where they are doing things like that. Anyway, uh, the answer would be the developer. So as we discussed already, in object class testing, we test the operations associated with the object, which means the behavior of that object. We are interrogating the attributes of the object. And one more thing comes up into play, that in object-oriented programming, your object can exist in different states. Now, the states also is part of a behavior essentially, but it means that if you have an object and the object is obviously represented by a class called fighter jet, and you are simulating a different running or development of that fighter jet. You are creating a new fifth generation uh, fighter, or a sixth generation fighter now. So you are creating your simulations and you are basically creating that object, which obviously is a computer generated uh, entity, and it will have different states. So the state, would it be whether it is running or whether it is flying, whether it is stopped, whether it is sort of like climbing up, whether it is diving. So there can be different behaviors and different states of that object. So you have to cover up all different possibilities of the states. So whether that object is running or stopped, whether the object is restarting, these could be different states, possible states of when you are doing the test. So you will be testing their different states, because that object can exist in different states, and these states can happen in a particular sequence. So basically, uh, as you will understand, that first you have to start any object, and then you would say you are trying to measure how fast that object is moving. So you have to start it first, like the case of this fighter jet. You have to first take off, and after that takeoff you would obviously do the loop, you will do your 5G maneuvers, or you will do your 7G maneuvers, and then you will do your 9G maneuvers, and all that. You will do that cobra, that cobra maneuver, or you'll do the loop, whatever different kind of flying patterns and testing patterns could exist. So basically what you're looking at different states of that object, which is obviously very critical. And there is a certain sequential approach to this, because that object will exist in different state, in a different timeline, in a different time frame. So you have to look at that as well, apart from other attributes that you would be testing, that you normally do in a normal circumstance also. The other point here is basically the inheritance. So your classes, as you know, in object oriented paradigm, you have a base class, and this base class, basically this is class A, is inherited by a class, a subclass called class B, right? So this is your class B. So class A is inherited by class B. Maybe here we will call it as a, you know, like we can call it as a car, just to make it a little simple. And here you can call it as your, sports car. or an electric car or whatever you want to call it, right? So your sports car. So this is a car, a generic class, which is your base class, and that is inherited by your sports car. So all certain features that are very common to any car, whether they are wheels, they are your steering wheel, their seats, their engine and everything else will also be available to the other car. But certain features obviously will not be represented in the child class. They will be inherited from the base class. So you have to be careful when you are doing a unit testing. You have to consider what is being inherited from the base class, and probably you have to create your own drivers sometimes, to supply you those values, those parameters that come from the base class, or that functionality that is inherited from the base class. Or you have to consider testing this whole combination together. So you have to plan a strategy how you would do that testing. Either you test the base class and child class in a coherent manner, uh, or you would create a driver class that will supply a certain functionality, basic functionality to the child class, and that is how you would achieve your testing. So that's what it depends on, and inheritance makes your testing a little more tricky, and you have to plan your test accordingly, and you also have to plan your strategies for this kind of object-oriented testing accordingly. Now here's an example of weather station, which is obviously comes from that chapter in the prescribed textbook Somerville. Here it talks about a system which is a weather forecasting system, and this weather station basically has certain behaviors which are obviously represented as methods. Report weather, report status, power save, remote control, reconfigure, restart, and shut down. So these are some of the measures that you have. And you can see that some of these are basically controlled by some instruments, and some of them are simply commands. So you have to test these behaviors, and that's the object interface for your this thing. So there are certain things that you would look at. So you need to define the test cases for this report weather interface, and you have to calibrate. Calibration means you have to give the right range of data to it. You have to initialize it with a starting value, whether you would start it from this value or that value. Then you will test, and you would also be careful about startup and shut down uh, things. So if you are like doing calibrating or you're doing testing, you can't do testing on a shutdown state. You can't supply any data in a shutdown state and do a testing. So you have to basically have a startup, and then you do certain other things like running your running this interface, or running different components that are associated in the system, and then you will reach out and you would be able to do some test, whether it is calibration or whether testing some data, some other kind of test that you can run on it. So using a state model, you have to look at the sequences of the state transitions basically. So that means first it is in a shutdown mode, then it has to be started up. So basically shutdown, running shutdown, well, that doesn't really happen. Probably you would be obviously running it, then you will be collecting the data, uh, then you will be summarizing it, then you will be transmitting the data, and whatever the correct sequence could be. So this one sounds to be more accurate, like obviously first you will be starting it, so you will start, then you'll do configuration, then you'll do running, then you'll do testing, then you'll do transmitting, and obviously finally you will do something called shutdown, right? So whatever is the correct sequence that you would be following, you have to be aware of that, and that is what is going to be critical when you're doing the testing of it. Testing can actually become a little tedious and little boring as well for testers, although still a lot of testing is done manually, and there are certain things which for which human cannot be replaced yet, because your programs haven't become so intelligent. Probably they still need to develop AI to a greater extent. But yes, today there are a lot of automation frameworks, test automation frameworks, which can be used to do the repetitive work of testing. And sometimes they can even do a better job than humans, because if you are doing repetitive testing, a human will get bored, obviously, doing the same thing again and again, and try and get distracted and try and miss some tests. Whereas these automated tools work diligently, continuously, without tiring, and do their job uh, to a great extent perfectly, without sleeping or getting tired or getting bored and frustrated. So automation test frameworks are being used extensively these days for doing some repetitive testing work. So one of these framework is called JUnit. The JUnit framework is a popular testing automation framework, which will, once you have created your tests, which will execute these tests automatically and provide you some sort of output, whether the test was successful or unsuccessful, report you the results as well. And sometimes there are some third-party tools which are used for reporting. So all that happens. But essentially, today's testing depends a lot on automated testing, because obviously these automated testing frameworks do a fantastic job without skipping anything. So while unit testing frameworks provide generic test classes, you can extend to create more sophisticated tests from these unit testing frameworks. So JUnit basically is a framework to do unit testing, right? But there are certain extensions which can be used along with these frameworks to use them for regression testing, to use them for integrated testing as well, and also reporting the test results. So this is very much possible and also used in that. In fact, that video that I've uploaded from that Edureka does talk about testing more in detail, practically what happens in web testing environment, and it does thoroughly cover that aspect in detail. So please look at that video definitely. Uh, so basically, many of these tools have GUI interface. They have a graphical user interface, and they can run all the tests that you have implemented, and they will report whether the tests failed or they passed. And there can be more extensive reporting through third-party reporting tools, which can be integrated with these tools like JUnit testing frameworks. So there is something called partition testing. A partition testing basically means that when you are doing testing, you will group your different modules or classes based on inputs. If they have a common input or similar kind of input which is being given in the test cases, you can group them together. So grouping common characteristics modules or classes to do the testing is also known as partition testing, or also known as equivalence testing, where you create equivalence partitions. And these equivalence partitions basically are certain categorizations that are done based on commonality of input data that you are testing. So there is also something called guideline based testing, where you have certain testing guidelines and you create your test cases according to those testing guidelines. So basically, these are some of the strategies for testing. And these guidelines are created based on the past experience of the kind of errors that normally programmers uh, they inflict when they are doing the regular testing efforts. So these guidelines are created, and based on these guidelines, you can create your test cases. So we discussed about that if input data and the output results often fall into different classes where all the members of the class are related. So basically input data and output results, they are fall into different classes, but yes, sometimes they have a commonality uh, in terms of being used. So that is how they are grouped together into a equivalence partition or domain. And basically, though they are separate classes, but they have a common behavior or common input, and based on that they are grouped together, categorized together, and this is called equivalence partition. So the test cases should be chosen from every single equivalence partition. So these are basically some recommendations that these automated testing frameworks also provide you certain templates or model test cases. Now these model test cases are already created based on the type of software you are developing, and there is a list of recommended tests or predefined test cases that are created for you, which you can configure, reconfigure, modify, or adapt them according to your requirements. You can do some changes in them. So these uh, testing frameworks as JUnit come with a list of testing classes, a whole templates of classes that have some sample test cases already created for you. And these sample test cases are further grouped together based on equivalence partitions. So you are supposed to pick at least a few cases from every equivalence partition when you are creating your test cases. So that means you don't leave out one particular aspect of testing. So you have to pick up a few test cases from every single template or from every single equivalence partitions and use that for testing your applications. All right. So this is the point basically which is being brought forward through equivalence partitioning. And obviously there are output partitions as well, where different classes can provide similar kind of outputs. So they are also grouped together. So it's a bit of it's a categorization mechanism that makes your work easier to define and decide on which test cases you must run essentially when you are testing your system. So as you can see in this equivalence partition, there's a range of values which are normally given. So you can see that especially if you are testing your you are testing a range of values, like you are testing certain conditional constructs or you are testing some loops. So you would say, okay, I'm giving a value of less than 4. Now I'm giving a value of 4. This is your border value. So you're running a loop from 4 to 10. So what happens if you give a value of 3? How does your program or your loop behaves? When you give a value of 4, what happens? If you give a value between 4 and 10, this is your range in which the loop has to operate, or the values have to be assigned to an array or whatever it is. This is your another border case. So this is your minimum borderline and this is your maximum borderline 10. So you're running a loop from 4 to 10. Now what if you run or you pass on 11, or what if it runs 11th time? What happens if it runs 11th time? What error do you see? So what happens if the value is greater than the borderline? What happens if it is supplied a value less than the borderline, and in between, as well as on the borderlines? So these are some of the classical test cases, and in equivalence partition you create test cases based on these parameters basically. So you can see that what input values you are getting and what output values also probably you are getting in many cases. So this is a classical example of what an equivalence partition would have. If the input would be in a certain range, then you would be picking up some test cases to provide that input. And mostly, as you are aware, the error happens. The bugs are normally sitting at the corners, as they say. So when you say the bugs are sitting in the corners, or the bugs are hiding in the corners, it essentially means that most of the errors happen on the borderlines. So if you are running a loop, mostly you will see that your loop will give an error because you were supposed to run it, say for example, 4 to 10. which essentially means difference of depending on what conditions you have given. Of course, if you have put an equal sign there, it will run 7 times. It will run fourth time. It will run fifth time, sixth time, seventh and eighth, and even 10th time if it is executing. You have to count from 4 to 10, which obviously becomes 7, right? But you would sometimes believe, no, I should get a 6 set of iterations. So you created an array with a index of 6, and here the loop is running 7 times. So I'm just giving a very simple example where the errors normally happen. So they happen at the borders, at the corners, what they call it. So this is the border line, and that is where the errors are prone to happen most of the time. When you are reaching the end, or you are at the beginning or at the starting, and you have given a value out of the range to that structure or to that class, that program that you have created, right? So these are a few things. So when you are creating a test case, there are certain general testing guidelines, which means that choose input for a proper range that force the system to generate all error messages. So try to see all the range. That means if you're supplying an input, try to give a null value to it. Does it throw a null pointer exception? Try to give a out of range value to it. Try to give a value within the range, uh, in the range. Try to give a value at the borders, starting and the ending point. So this covers the whole range of values. So try to generate all different kind of error messages that happens. Buffer overflow again is one of the very vulnerable areas in your programming, where normally you tend to have buffer overflow. So to test that, you must try and deliberately make the buffer to overflow to see whether your software is handling that buffer overflow and how it behaves, whether it crashes. Uh, in old programs, but it doesn't happen in today's modern day languages because they don't allow that to happen. But in old languages like C and C++, the buffer overflow attacks were very common. And what happened in buffer overflow attack is that if you have created an array or a linked list or any structure to store values, you would supply much larger data to that structure, to that array, say for example. So what used to happen typically in C programs, any extra data that you supply actually obviously cannot be stored in that memory area. That was now stored in a separate reserved memory area of your system, which is called buffer area. So hackers used to exploit that. They used to exploit that vulnerability by deliberately putting up their executable commands. They will be putting up some batch commands, some system commands into that buffer, into that pointer, and obviously these commands, you know, this input will consist data more than the command could handle. That particular array or that pointer array could handle, or that memory area or that variable, whatever we have declared, could handle. So all that extra data would go and execute in buffer memory, and that is where it is being allowed to execute in the buffer memory, which means your system commands can run in the system. And these system commands basically are also known as the sometimes they are called the, what do you call that, root commands. So these are root commands which are executed as a root user, and that would either change the privileges, access privileges of the system, and provide access to an unauthenticated user, to a hacker sitting somewhere else. Or they could simply plant executable code, which basically is a rootkit code on its own. It's like a rootkit program. It is called rat. uh, you know a rootkit attack Trojan, I think, is the full form of it. So it's called a rat. So we'll plant a rat, and that rat can hack your system. So it used to cause a lot of buffer overflow attack vulnerabilities in the system, especially old systems which use C programming or C programming language routines normally. In today's language, deliberately the pointers are eliminated and buffer overflow attacks are prevented by not allowing any buffer overflow. But even an exception will occur if there is a buffer overflow. So that exception will give a a error message, and sometimes it discloses a lot of system information while it is giving that system generated message. That error happened here at this routine, at this line of code, at this, and it also gives details of the server that you are running, program where it is being hosted. Sometimes the location is also mentioned there. So these error messages are definitely again a security vulnerability itself. So you have to create customized messages for exception handling as well, where you will create certain messages which doesn't disclose system information to the user and rather give a friendly message to the user saying that you have entered this wrong information and please go and enter the right information in that control or in that file or whatever it is. So this is what happens in general in general cases. So you have to be aware of these buffer overflow errors as well, right? You have to repeat the same input in a series of inputs to numerous times to do a thorough testing. Yes. You have to force invalid outputs to be generated. So that means try and deliberately try to give data to the testing routine or testing class, whatever you are testing. So it gives an invalid output. So these are some of the cases where you're doing the testing, right? So force the result that are too large or too small. That means out of the range. Testing is very, very important, which has to be done. How the system behaves if it is given data that is too large? As I said, too large data, does it lead to a buffer overflow? If it does, then that means buffer overflow attack is possible. It's a vulnerability. It has to be fixed. If it is too small, then how does the system behave? So all that is part of the general guidelines of testing. Today, a lot of development happens as components. The systems are developed as components that are executing remotely or in a distributed environment. So what you are testing in that case is, and the example here is again given for that weather station system, which we'll look at again in a few diagrams. So you have to access the functionality and you have to test through a component interface. Now, what is this component interface? Is basically the communication or the methods that facilitate communication between component 1, or you can call it as component A, and component B. So in between there is a communication channel which is established by different, I did mention that sometimes it is in the form of protocols, sometimes it is in the form of dedicated methods, whether it is RMI, I've told about remote method invocation, that is a technology in Java, whether it is Corba, I mentioned about common object request breaker architecture. These are some of the terms, or whether it is SOAP. In today's web services SOA architecture, it is SOAP, where you are sending XML based data messages, SOAP messages. So this is the component interface. So you have to do the testing of that. So basically, if it is a SOAP interface, then you have to send SOAP messages, testing messages to the component to see how it behaves. So that's why your testing strategy has to be planned accordingly. So testing composite components should therefore focus on showing the component interface and how it behaves, according to the specification. So basically, these are a few things that you have to be aware of. So also, you can assume that the unit tests on individual objects within the component have been completed. So when you are testing component, normally the components are a combination of smaller classes. So you will have some smaller classes which have to be unit tested first. So component testing also falls under integration testing. Although this integration may not be a physical integration in the sense that you are picking this class, picking that class, putting them into one package or one space and executing it. It could be more of like done remotely because this sit on remote servers. So that is basically you have to be careful about when you are doing the component testing. And as I said, the components have to be, or the classes of those components have to be unit tested first, and then component testing happens. So it falls under basically under integration testing phase basically. So it is integration testing anyhow, although it's different way of integrating them. It could not be physically integrating them. It could be like remotely passing the SOAP messages or passing the data remotely to them through the component interface. So system testing again obviously is the next stage. It is again a integrated testing because you are integrating the whole component, the whole set of components or classes together, the whole units together, and system testing is done where basically you are integrating all the components and you create a version of the system. So basically you have a working prototype of the system now, right? And this working prototype of the system is now tested. So you will be testing how the components interact, right? You will be checking if the components are working together. Are they compatible with each other? Are they transferring the right kind of data and so forth across all different interfaces? So this is what you do in system testing. So you test the emergent behavior of your system. That's what basically you're doing, emergent behavior of your system. If you are having any reusable components during system testing, some components which have been separately developed or off-the-shelf components can be there, which basically are third-party components. All of them are integrated to the newly developed system and then they are tested. So components can be developed by different team members, yeah, and obviously they are developed by different teams, so they have to be tested thoroughly whether they are working together in a collective manner or not. So this is what happens. In system testing, many times there are separate teams or expert teams like your ITG groups that are involved in system testing, because here you have integrated the systems. So as I said, unit tests are done by the developer team members who are developing those classes or those modules, and system testing is done after integration of the system, all the components together, and normally they are done by the external testing engineers who sometimes form the task of that independent testing group, ITG. Use case testing is another method of testing where you create the use cases, and I think you are aware of them because you already use them in third years when you are doing your testing. You created your use cases that I am logging in as a manager. So the manager logs in, what things manager would do, what manager can do. The manager goes to the inventory section, the manager enters or captures some inventory data, or the manager modifies some stock inventory data or whatever. So basically you are doing the use case testing here. The user actually somebody acts as a user and go and operate that system, and basically you do the use case testing. So it's testing, or the test cases are developed based on use cases, and they identify the system interactions and they form the basis of system testing. So again, it is an integrated testing and it's part of the system testing, but obviously the test cases are created using use cases. One use case would involve several system components. Yeah, you might be using different set of components or classes. Use case testing is very important and very vital because it enforces that interaction between different components occur. Because when you are doing a use case testing, you will be using different classes and components together. So you will switch your control from one class, one component to another one, and you will basically go through a set of interfaces and a set of classes. So that means that you will be forcing the system, you know, you will be forcing the system basically to uh, function across different layers, across different component levels, and that is why your use case testing becomes very important. So a sequence diagram associated with use case components, documents and components interactions are being tested. So what you do, you normally create your sequence diagrams, right? So your sequence diagrams forms one of the way of creating use case test cases, and that forms the part of it. Now this is an example of a sequence diagram, a sequence chart, where obviously the information system is described, and the information system is that weather forecasting system, and there is a user here, and the user basically is requesting a report, some data, and you have satellite communications. You have SATCOM, which is a component which communicates. It's a program or a component of a program which communicates with the satellite communications. There are other instruments here and some of the other interfaces of this application which communicates with weather station. There will be a communication link between weather stations. So there will be multiple weather stations over here. These weather stations normally communicate with a satellite. So they are communicating with the satellite. So you can see that there's a communication between weather stations, between them. So this station 1 communicates with station 2, and this communicates with station 3 here. And then this station 1 communicates with satellite as well. And satellite sends some data with station 2 or to another interface in station 3. So you can see there's a complex component communication happening in this. So satellite communications is being sent, and some data is being sent to the to satellite communications module there, and basically a weather report is being sent to the workstations. So basically satellites collect some data, they send they report some data to the weather stations, right? Now these weather stations then control sprinklers, basically the irrigation system is being controlled by them. So the weather station will tell whether the sprinkler will start sprinkling the water on the crops depending on the data it receives from satellites. So you can see that the satellite communication helps to report weather to the weather station. The weather station basically communicates a summarized data to through communication links to the maybe a database, which is a weather data database somewhere. So these weather stations are connected to a database in a data center, and from there they are fetching and they are communicating the data as well. So you can see that it's a complex diagram which is represented by sequence chart here, and you have a request report first, then an acknowledgement goes that the request has been received, then a report weather method is invoked, which makes a summary of the data. This summary of the data or summarized version of the data goes to the weather data. Some data obviously from the weather data database comes back, to the communication satellite links. It gets summarized and it is being sent to weather stations. So the data comes from here, goes to the weather stations. From the weather station, the data is sent as a report, and the report is sent as a reply to the user. So you can see that the user requested a report on some weather data. Satellite communication happened. Some data was sent to the weather station. Weather station sent some data to the communication links, and through them it went to a data store, whether the weather data is stored. Similarly, some weather data is sent back as part of this report. So basically, there is to and fro communication of data between the weather data database, and finally it is sent as a report to the user. So this is a set of a complex system which shows that different components are working, and communicating with each other through some methods uh, that we have created and some interfaces that we have created, and then finally they provide you the data and they provide you acknowledgements of the request, and they also provide you, you also send acknowledgement back that you have received the report now. So this is an example of how a complex uh, system would work, which consists of different components sitting remotely, sending data through interfaces, sending, using certain methods to invoke certain functions, and they also have different states. So could be that the sprinkler systems are, in a stop state when the weather data comes, and the weather data says that, or the report or the weather report says that the chances of raining is less than, say for example, 70%. So the chances of rain, by doing some complex calculations, can say that the chances of rain is less than 70%. Then the sprinkler systems will start and will start the irrigation system. So the irrigation system obviously is automated and controlled by this complex system, which depends on the satellite weather data and the data stored or collected by weather stations and stored in a particular weather data database. So this is what all happens in a complex system. So basically, that would become a typical example where, and you can see that different components will have different states. So at one stage the sprinkler system is, in a stop mode, and in one stage it would be, it has to go from stop to start mode, and from start mode it has go to active mode where it starts sprinkling the water on the crops. So there are different states and they happen in a particular sequence as well. So that's basically it as far as this example is concerned. So the same thing is being explained here in this slide. So when there is a request for a report, an acknowledgement must go. Some summarized data has to go, and you should create some summarized data to check whether the report is correctly organized or not. So the weather station, when the request comes, would send a set of results, and then a summarized report again is being generated. So you can create some raw data corresponding to the summary that you have prepared for the test of the SATCOMs. So you can have some test data created here, and based on that test data you can check whether your weather station object is correctly behaving, is producing the correct data, or is producing the correct report or not. So this raw data becomes the test data for testing the system that you have just created. Okay, so no matter how hard you work, you will never able to do 100% testing. It's impossible to do a exhaustive testing, as I said. It's never an ideal situation to achieve, to say I have tested and I can be 100% sure of there's no error which will happen. Are you guys still with me? Hello?
Yes, sir, you're with me.
Okay. The thing is, yeah, I can't see any, any activity on that except a fixed screen. It doesn't even tell me whether, whether some input is happening or whether something is happening in the background or not. It completely locks down the screen, which I don't like. Sometimes I would like to see a small timer here to see that, how much your presentation is still active and it is being still being listened to and all that. Yeah. Anyway, so basically we are looking at these testing policies, and we can say that uh, there are certain combinations of functions or test formatting that can be tested through the same menu. So basically, you can create certain menu options. This is again another way of using use case testing, because all your use cases will eventually become certain interface objects, whether it is a login section, whether it is a menu option. So the manager will go and click a particular option where uh, a manager is supposed to go and click in a menu option, or a admin person will do a different set of activities to access some data. So when you are making these test policies, you should make sure that all the system functions that are accessed through menus should be tested. That's the message that you are giving. So you create your testing policies that you test for all the use cases, you test for all the functionalities that are possibly in the system, and all that. A combination of functions like text formatting are accessed through same menu must be tested. So basically, if there is any commonality between different interfaces, there are different set of options. We already discussed about that in equivalence partitioning, that if you have similar kind of input or similar kind of functionality, you should group those test cases together and test them. So all functions must be tested with both correct and incorrect input. So we are talking the same thing again and again, but this is now important. Test-driven development. Now what happens in today's world? We use test-driven development, and especially in today's agile and extreme programming environments, test-driven development is very critical. It's very much in practice and in fashion, where you create the test cases right before you start even coding. So you have your test cases. So it might sound funny here, but you have a test case to start a car, right? Now, point is, you are starting the car without putting the engine into that car, right? You haven't put the engine in the car, and you would obviously go and sit in the car and close the door and turn the ignition switch. And obviously, you shouldn't be too surprised if they tell you that there is no engine in the car. So if there is no engine in the car, it won't start. Obviously, engine won't run. How hard you press the gas pedal, whatever you do, still it won't run. But this is also a test. This could be a test. It sounds funny in the example of a car, but this is how exactly it happens, that you create a test case without even starting coding. Now, when there is no code, the test will fail automatically. So the first step towards testing is that you create your test cases. The first step is they will fail because there is no code to implement that functionality. It's just like there's no engine in the car. But once you have got the engine in the car and you repeat the same test, and obviously the engine is connected to the battery and the self is also working now, and now you press the ignition switch, you turn the ignition switch, now the engine will start, your car will start now. So this is a test. Obviously you start by in a test driven development, you start by creating test cases without even writing a piece of code. So test driven development is an approach to program development in which you interleave testing and code development. So what you do is you create the test cases first, then you write the code, you do the coding. Obviously you create a test case, the test case will fail. You go and do the coding now. Once you've done the coding, the test case test1 T1 will pass. Then again you will create a test case 2, and again you're going to go and do some coding again in that whole in that whole class or in that whole module, and you will run this test case 2 now to see whether the test case 2 passes or it fails. So this is how you do the testing, and it becomes quite a streamlined, methodical, and a compulsory process that is found very useful typically in agile method programming, in agile agile methodologies. So if you are doing your extreme programming or you are using your Scrum, so this definitely works on test-driven development approach, right? So the tests are written before code. You can see this is the statement I've been stressing upon. Tests are written before code, and passing the test is obviously a critical driver for the development. So if this test one doesn't pass, if this test doesn't pass, you won't be proceeding further to coding level 2 because this test hasn't passed. So after this test has been cleared, then only you will go and write the test 2, and then test 2 would force you to do coding in second phase. So that's how it works. So you develop the code incrementally along with the test for that increment, and you don't move to the next increment until the code that you have developed has passed the test. So TDD was introduced as agile method approach in extreme programming, and it can also be used in plan driven development PDD processes as well, which is again an extension of the same test driven development. Nothing big about it. So in test driven development, identify the functionality, write the test case, run the test, see if it fails or it passes. If it passes, you go and do the next iteration of your functionality coding. Sorry, excuse me. Or you simply, if it fails, you implement the functionality and you refactor. Refactor means you do the changes. You just go and fix the problems, or you go and change the code. So you do the refactoring of the code, right? So this is what happens in test-driven development. Very important aspect of development in agile methodology specifically. So again, the same thing. Identify the increment of functionality. It could be a very small increment. If it could be just a few lines of code, doesn't matter. You should follow the same process. Write the test for this functionality and implement this as an automated test. Normally, these approaches work with automated testing frameworks. So you create a test cases already, and whenever you type the code and you run the code, automatically the testing happens. So what happens in this case is basically your testing happens automatically. You don't specifically go and write manual tests. So whenever you are adding new code or creating a new function, adding some functionality, automatically the test cases are created for you. And as you implement that functionality and you run it, the test cases are automatically executed, and you do the testing, and it tells you whether the test is failing or the test is passing. Right? So you start by a failed test, of course, but once you have implemented the functionality, you rerun the test, and this time you should get a successful test run. So once all your tests run successfully, you move to implementing the next chunk of functionality. So it's a very methodical, stepwise approach, and it makes sure that you don't really do too much of coding and then you start sitting and testing, and you tested something and you forgot something else. It could happen because now you have created a very complex system with many different interfaces, a lot of different functionalities. It is quite possible that you would test some and forget some other ones. But in this test-driven development approach, you can't miss testing a particular module, because first you will move to the next module only after you have passed a test. So it enforces that you test every single piece of code that you have developed, every single function that you have developed. That's how it works. So it covers the whole code. Every code segment is covered through testing, is associated with the test. Regression testing is done, which is automated. So regression test suite is developed incrementally and as the program is developed. So you keep on adding new tests to the regression testing suite, and regression testing won't test the whole program from scratch. It will only test those components that have been modified, that have been changed, or that have been refactored. So regression testing uh, is obviously less time consuming if it is automated, and it covers all different aspects of your testing. Okay, since you are doing this exercise one by one, it makes your debugging simplified. So that means you can easily pinpoint where the error is. So if the test fails, because you have done thorough testing after every single introduction of line of code, and only you move forward once the test is passed. So that means that most probably you will find fewer bugs, and it also makes your debugging easier because the newly written code needs to be checked and modified. Yes, and definitely if you find errors, you will go and change it. So it doesn't allow you to move forward without checking you at every step that you take in terms of writing your code. Many of these systems generate documentation. Many of these testing frameworks also generate some reports which serve as system documentation. So these tests themselves are a form of documentation to say that this input was given and this was the output that was received. So they form the basis of your documentation to say that this module was found, this module was tested and found working properly, and this input was given, and this is how the output came out. So it becomes a system documentation as well, and it describes what exactly the code should be doing, because it explains that this is what the functionality of the code is, this is what the input of the code is supposed to be, and this is what the output of the code is supposed to be. So it documents all that aspects, and that makes sure that you get all of these things working properly. I discussed about in regression testing earlier also, which means it is just testing which is basically checking only on the changed aspect of your system. And most of the time these regression tests are automated. So whenever you do any changes in the system will automatically execute regression tests and will go and test that particular component or that piece of code only. So it makes sure that if you have made any changes to the software, you haven't broken the functionality of your system. You haven't introduced some errors in that change, and the system still works fine. Normally, regression testing can be done manually. So regression testing is quite tedious if you are doing it manually, but with automated testing using these frameworks, yes, it becomes quite simple and quite easy to follow, right? So all the tests are rerun every time you make any change in the program. So the test must run successfully. That's the point here. Release testing. Release testing is basically a black box testing. It's a black box testing, and release testing is a process where you are testing a release of the system. That means a particular version release is tested. And normally an outside development team or a ITG group will do that testing. So the primary goal of release testing is to convince the client, basically of the system, that it is good enough for use. So you are testing the functionality in a release testing and the performance as well. So it is also called a non-functional testing. You also do some sort of non-functional testing there as well, where you check the dependability, the security, the performance, and the functionality of the system. And it's basically a black box testing, which means the tester is not concerned about the logic, about the intricacies of your software or the complexities of your software. How many methods you used, how many classes you created, what interfaces you created, they are not really bothered about that. They'll simply go and sit on the system and do a test by supplying data. Sometimes they may create use cases, use test cases for guidance, but essentially it is done simply as a black box, which means you don't know what lies inside the box. You are just supplying some data, or you are using the system and you are trying to see how it operates, how it runs in a particular environment, right? So here the tests are based on system specification. So when you go and do you have a what you call that requirement specification document, requirement specification document, RSD, right? That requirement specification document serves as the benchmark to do the black box testing. So that list will be used as a test case for black box testing, right? That happens as part of release testing. So release testing is part of a system testing, but it is an advanced stage of system testing. It's not the initial stage. It is actually the almost like a final stage. Uh, and normally a separate team, what are the main differences? A separate team uh, that has not been involved in the system development should be responsible for release testing. That means it should be done independently. So that is why you need to have an independent testing group of engineers doing that testing. System testing by development team should focus on discovering the bugs, right? In the system, which is also called defect testing. The objective of release testing is basically to check that the system meets all the requirements and is good enough for external use. So it's kind of a validation testing. So it's basically testing the overall system, how it functions, not really getting into the details of it or intricacies of the system to see how it is being implemented. So that's the basic difference between white box testing and black box testing. Whereas in white box testing, you go and look and analyze the code and see the functions and the classes and the objects. But here you don't do that. You simply just test the functionality and the performance and the behavior of the system on a larger scale. So that is why it falls under validation testing, not verification. And the previous white box testing falls under verification verification model. So that is verification, as we call V&V model, and this is the validation testing, which is the final stage of your V&V model, right? So requirement based testing, as I said, you are basically looking at the requirement specification document, RSD, to do the testing and examining each requirement and developing a test for that. So the example goes for that ment care system, which we have discussed a few times, which is a case study in your textbook. So this is a typical example of it. If a patient, basically is a patient management system. So if a patient is known to be allergic for a particular medication, then when you are prescribing that medication, the system should actually send you a warning. So you have coded or you have implemented the functionality to keep the details of the allergy profile of a patient, and whenever any medication is given which can trigger that allergy, there should be a warning sent, and the doctor should be given a message by the system to say this particular system, this particular guy is allergic to, say for example, oxyfloxacin. It's an antibiotic. So oxyflex. So it's allergic to oxyflex. I'm just giving an example here. So or Oflox. There are different brand names there. There are different medical brand names where it is marketed. So if somebody is allergic to that antibiotic, then obviously it should give a message to it. So if a prescriber chooses to ignore that allergy warning, they shall provide the reason why they are being ignored. So maybe sometimes what happens that a doctor still would prescribe that, okay, now say for example, some guys are allergic to a lot of other things, but some allergies are tolerable. Like whenever a vaccine is given, even like you take a flu vaccine, some people develop a mild fever or a mild flu-like symptoms. So which is normally ignored. So that means you are slightly allergic to that vaccine. But sometimes for to get the immunity shot, to get the immunity up, you would basically you would definitely allow that that kind of medication to be permitted because you think that is important in this situation. So that is why it should have a feature to bypass it. So these are a few things. So in this example, requirement test could be set up a patient record with no known allergies, prescribe medication for the allergies that are known to exist, check if the warning message is not issued by the system. You are also trying to check the system shouldn't give you false messages, which is called sometimes the false positive results, which means that you don't have any allergy, but the system is saying no, you have allergy. So you would test with the system with the patient which does not have any allergies. You should test a patient record with known allergies to see whether the prescription of the medication provides that warning and the warning is correct or not. Set up a patient record which has allergy to more than one drug, right? Prescribe both these drugs separately and check if the warning of each drug is issued or not correctly. So you can look at different scenarios and different combinations and all different possible scenarios when you are creating the test cases. Prescribe two drugs that the patient is allergic to. Check if two warnings are coming and they are correct warnings. So all that happens in your your requirement tests, right? So yeah, you can carry on and on. Prescribe a drug that issues a warning, and now you overrule that warning. So if you overruled that warning, check if the system allows you to overrule to that warning and provide and requires the user to provide information explaining why the warning was overruled. So that means the doctor must provide an explanation. Why are you still giving it? If you know this user had allergy to particular medication, but still you are prescribing, the person can say that still this drug is very effective in this treatment, and probably I'm giving it in a smaller dose. I'm reducing the dose for this particular vaccine or this particular medication, or I'm giving I'm giving a probably what do you call it as a counter drug to that situation. That means if you think the person will get an allergic reaction, you might prescribe an anti-allergic drug to it. I'm also giving an anti-allergy drug, like something like I know there's a drug called Avil, which is anti-allergic drug. Maybe you can suggest me another drug that is an anti-allergic drug, which doesn't come to my mind immediately, but I know this one definitely is an anti-allergic one. Anyway, so this is a scenario we are talking about, right? So this whole set of things is given in detail. I won't go into detail here, but obviously you can see that somebody is behaving as a user of this system like a nurse who specializes and who has the responsibility to visit the patients. So she goes or he goes and checks the patient at home and trying to ask if there are any side effects. George says, yes, I have a side effect. So first it must print a schedule for the nurse. Then there should be some summary information about the patient, medical records, what medicines have been prescribed to the patient. This can be downloaded on the person's laptop. Yeah, the data have to be encrypted. So you can see, you can check all the different stages of this complex system, at every point of time, and see that the nurse goes and visits a patient called Jim. Uh, he's been given a medicine of depression. My goodness. So basically, he's awake at night. Now, many of these anti-depressants cause a side effect of lack of sleep. I know they do other funny things as well, but let's stick to that. So George looks up to the Jim's record and is basically prompted to give a key phrase to decrypt the record, and checks the side effects. He checks. I mean, normally nurses are quite intelligent these days. They know that a particular medication has certain side effects, but this nurse seems to be a little bit dumb here. So they check that sleepiness is no known side effect to the problem. So suggest that you go to the clinic and you get your medication changed. So this is a whole big case study given to you. And yeah, so basically you can go through it, but this is like a uses a scenario base, and through that, based on that scenario, you can develop your test cases, right? So what could be the sample test cases? Authentication by logging, downloading and uploading specific records, home visit scheduling, encryption and decryption of patient records, retrieval and modification of the records, links to the drug database that maintains side effect information, and notifications from the system for call prompting, which means the system will notify you about the next appointment. So this is all that what happens. You're testing the functionality. Now there are some non-functional aspects. Non-functional aspects basically test non-functional aspects of the usability, how user-friendly your system is. So usability and performance. So these are the things. So performance and usability are part of non-functional testing. So part of release testing also is to test performance and reliability, and test different profile of the system usage. Performance test normally involves planning a set of tests where you increase the load uh, slowly. So you start supplying more data, you start supplying more number of users to the system, and then you test the performance. Now this is an important aspect, till the system breaks. So it is also known as stress testing. Now stress testing is basically another aspect of performance testing where you would look at the point how the system handles the stress, the data load, and when the system breaks. You would also see if you start putting the number of users in terms of performance. So this is your number of users, right? Users, and this is your performance P, and you would see that how does it work if the users increase from 1 to 10, 10 to 20, does the performance increase or decrease, or what happens to the performance? Normally there could be a graph like this. Basically, as the number of users are low, the performance goes down. Now how does it go down? Does it go down like this, or does it go down like this? You have to look at it. So if it is going down like this, this graph, I want to ask you, this is graph, this is the data series A, this is data series B. Which one is the better data series? This one or this one? Is A better than B or B better than A? So this is what happens here. As the user increases, the performance go down very quickly. Yeah. Hello.
A is better than B.
A is better than B.
B.
A is better than B. Is that what you're saying?
Yeah.
Okay, A is better than B. Uh,
Uh, but no, no, no. I think I'm incorrect there.
okay. Uh, well, it depends. It also depends on the situation. In fact, we can agree on that as well. You can see that the system, it depends how what is acceptable to the user. It says that the performance doesn't really go down for a set number of users, and only when the number of users increase, in a small number, the performance goes down drastically. That's how it works. So it's telling about a behavior of a system. In the other hand, you see that the performance is going down steadily, you know, with the number of increase of users, but after a level, the performance becomes stable. You see, the performance is not going down even if the users are increasing drastically. So it is telling you two different behaviors, how the system behaves. The client could be happy with A. They say, okay, only if the user number becomes like 1,000 users, then only the system goes down, which is fine. It is acceptable to me because it happens only in rare cases. You know, it doesn't happen in usual cases. I am happy if the system is performing well and fast enough. If the number of users are less than 1,000, they are less than 1,000. So it could be what is the acceptance criteria for the client, you know and that is what decides what is a good performance and what is a bad performance. So it depends on that, right? So you'll find somebody who will be happy with situation one or state one or state two, as we described in two different graphs, right? User testing. Okay, user testing is basically when a customer or a user rather sits on the system and starts testing the system. So it is a testing process where the customer provides the input and do a system testing basically. So user testing obviously is one of the last stages where a comprehensive system test is done, and obviously the release testing has also been completed. So you have done the release testing on its own. Now you give it to the user to test it. The user testing can be further split it up into alpha testing and beta testing. So we'll come to those terms as well. So reason for this is that uh, you know it is tested in a user working environment, and that has a major effect on the reliability and the performance of the system, right? So you may be testing it in your labs, but the real testing occurs only when the user starts using your system. So your lab environment still can be what you call as you know a standard operating environment or an ideal uh, conducive environment, whereas the user environment can be more stressful for the system. So it can give different kind of performance results in two different situations, and that is why this cannot be replicated in a test environment. So that means most of your cars, when they are tested, when you are given a mileage claim that this car does, how much you normally do. Well, in India, we calculate the mileage that this car is doing 20 kilometers per liter of petrol, per liter of diesel or petrol. So obviously, this is a high mileage car, more effective and more affordable, efficient car in terms of fuel consumption, compared to one that gives you 12 kilometers a liter. But I think you can here you do it for 100 kilometers. You know how many liters for 100 kilometers? So that means you are consuming 5 liters for 100 kilometers. So you can look at that, but that could be a claim which is done in a lab environment. They normally put that car into a onto a like a treadmill kind of a machine, and then run it with a small. They'll put a small like 100 mLs of petrol in the car engine directly, and then run it. And that is how they come to that. But when you run that same car on a highway, or probably in a more urban environment, you'll see probably your car will struggle to make 16 kilometers a liter mileage, which is basically the real testing environment, you know. So the lab environment always is different than the real testing environment. That's what the point is to be made here. So I did say alpha testing is what? Alpha testing is that the user of the software works with the development team to test the software at the developer's site. So alpha testing is sometimes in-house testing. It is done by the employees of in-house. Say for example, Microsoft created a new version of MS Office and they call it now, rather than 360, they call it as 370. You know, I'm just joking, just giving a funny example here. So they call it as 370. Now they would give it to their own customers, their own employees first to test it. Many times before releasing a software to the users, it is tested in-house, and that is a typical example of alpha testing. So that is a typical example of alpha testing, whether you do it like this or you draw it like that, whatever, doesn't matter. So that is a typical example of alpha testing, and that is done in-house. Now beta testing is basically where a version is released for testing to the users. Normally you see beta release are released on internet, are released on beta versions are released on like your release sites like your Google uh, Play Store or on iStore on iPhone. So beta versions are released and they are marked as beta versions, which means they are there for testing. So they are normally given for free for people to use them. And normally it is a testing experiment to see, and these beta versions normally send a test report. So you have to agree to that disclaimer as well, that this is a beta version. This can still have some bugs, and this is given only for testing purpose to the customers. So if you have any loss uh, of data or any loss of life or whatever I think disclaimer would say, then you can't sue the company to say, oh, because of your software I got hurt, or I lost my data and I had a business loss. You can't sue the company because they would claim that this is a beta version, which means it is only there for testing and it is supposed to have some bugs. So it is still in the phase of rooting out those bugs and those errors in the system. Acceptance testing, obviously, this is the testing where the customer tests the system or the client tests the system, whether it is ready to be accepted uh, from the developers. And that is done in a customer environment. So this is these are types of user testing: alpha, beta, and acceptance. Right. So as you can see, you create an acceptance criteria first, test criteria, plan acceptance testing, plan a test, derive acceptance test, run these tests, negotiate the test results, and then you accept or reject the system. And you create a testing report as well in the process. So this is how acceptance testing works. You define the acceptance criteria, plan the acceptance, derive acceptance tests, run the acceptance tests, negotiate the test results, and accept or reject the system. So these are important steps of our acceptance testing process. Okay, in agile methods, basically the user normally is involved with the team itself. So the user or the customer is part of the development team in the sense that whenever you do one iteration of a software, you will or the user will actually the customer or the client will do a testing on that. So you create one release of prototype and then you give it to the client to test. So it's basically this testing is also not done like right in the end, but this testing has many iterations and many phases. So it is responsible for making decisions for the acceptability of the system. So basically you create version 1 prototype, V1 prototype, V1 prototype 1, and this is done as acceptance testing by the user or the customer. So tests are defined by the user and customer, and are integrated with other tests, and then they are run automatically. So a lot of this acceptance testing is also automated today because the client is sitting there with the development team, or metaphorically, I mean that the client is very much in touch with the development team and would basically visit the development team quite often, quite frequently, to test different release and different versions and different prototype releases. So basically they'll go and they'll test version 1, prototype 1, version 1, prototype 2, whatever it is. So they will do this acceptance testing for every single release of prototype. So there is no separate acceptance testing process in that agile, in the agile scenario. So that is critical about it. So the main problem here is whether or not the embedded user is a typical or can represent the interest of all the system stakeholders. Now, a challenge here in this kind of scenario with agile approach and this accepted testing happening in an automated manner is that whether the tests have been created correctly or whether the stakeholder who comes and do the testing, because there's normally allocated 1 or 2 persons who will come and interact with the development team quite often and frequently. Now, they may not be the thorough user of the system. There may be like 10 different profiles of the system users, and then may not be knowledgeable about all those 10 different user profiles. So sometimes they may not provide full set of information, or they may not give information to derive a full set of tests that are possible and that should be done on the system. So these are some of the challenges with agile methodology anyway. So the key point is obviously that the testing can only show the presence of errors, not the absence, and it cannot demonstrate that there is no faults. Development testing obviously is the responsibility of the development team, which is again, as I said, white box testing. And a separate team should be responsible for testing the system, which is the system testing, and which will do the black box testing, BT, right? Before it is released to the customers. So development testing includes unit testing, definitely, where you test the individual objects, classes, and methods and components. That happens, and in which you test either the partial or mostly the partial, not really the complete testing, complete system. So when you're doing testing, you're trying to break the software, right? And you have some guidelines, testing guidelines also, which are effective in discovering the defects of the system. Wherever possible, you should do automated testing or write automate test, because that definitely ensures that a thorough testing has been done. And these tests are embedded in the program or into the framework. Sometimes they are integrated with your development environment. These testing frameworks are integrated with the development environment. So they execute every time there's a change in the system. So test first development, or which is also called test driven development, right? Test driven development, TDD, is an approach for development where the tests are written before the code is to be tested. So in test driven development, you write the test first and then you do the coding. So scenario for testing involves inventing a typical usage scenario and derive the test cases from there. That makes it more practical. So scenario based testing, we saw one when you actually use you take the example of use cases and then you derive your test cases, right? Acceptance testing obviously is a user testing process, which says that the software is good enough to be deployed in the operational environment. So these are some of the key points that we discussed in that. So probably now I'll go to demonstrating Selenium examples to you. Are you guys still okay? Hello?
Yes, sir, we're okay.
Okay, you haven't slept. You can You can have a small break if you want, or should I just continue? Okay, I have uploaded another set of slides there.
I think it's continue.
Continue.
Sir, please continue.
Okay, that's what I heard. Great, thank you. So basically, let me look at some of the slides here. Where were those slides? Okay, then software engineering. Okay. So we'll talk about some software testing tools. Well, obviously we have gone through. Can you see my screen?
Yes, sir, we can see your screen.
Okay, great.
Yes, you can.
Excellent. I won't go through the basics here. I'll just come to the. You have already understood the unit level testing, integration testing, system level testings, functional testing and non-functional testing. So you can go through these set of slides. I've uploaded them on Moodle as well. Obviously, you have to go through different phases of test lifecycle, which means test planning, test designing, and text execution. So test planning is obviously how to plan the test. Test design is how to test, create a framework or a design, and finally execution of those tests to actually run those tests executely. So this is a software test lifecycle. These slides are up there. I won't go much into detail, but yes, definitely you can see that uh, there are a few things like acceptance criteria, planning and design, and you go through the stage of executing, defect tracking, and bug fixing, review and audit. All that happens. So there is always it starts basically from step one, which is identify requirements, right? Identify your requirements. If I just I'll click on the slideshow there. So you basically looking at identifying the requirements, then acceptance criteria, strategy planning, executing, defect tracking and bug fixing, review and audit, and acceptance as the baseline. So basically you can see that obviously you've gone through from requirements to acceptance criteria, which means again is a list of requirements that is given by the customer, the client. Your planning and designing of the test, executing the tests, defect tracking, and finally reviewing what were the errors and what was the reason of those errors. So you can create an audit report to make sure you train your developers not to repeat those errors in future. So that's very important. Sorry. So basically you are doing all these things. And finally, we'll come to Selenium IDE, which is an open source automated testing suite for web applications across different browsers and platforms. Normally, Selenium IDE is available for Firefox and Chrome. Previously, it was only available for Firefox only as a plugin, but now it's also available for Chrome. But it doesn't support a wide range of browsers. But there is something else which does support a wide range of browsers as well, which is the new version, which is called the WebDriver, which is part of a Selenium testing framework. So basically, the older version is IDE, integrated development, a scaled down version. You shouldn't call it older version, it is still there. But this is an IDE environment which acts as a plugin for browser for testing different applications. Then you have something called Selenium remote control. The detail of this is in that tutorial video I have shared link. 4, especially that long one, the one from that girl Akanksha from what is the name of the company? I keep on forgetting that. I think Eureka, something like that, whatever the name is. You can read that. And so this is this is truncated version. Remote control RC is not used in today's way, because you have web drivers. Now these web drivers work straight away with the web browser. Before, these used to be the interfaces, like IDE and RC were two interfaces between the server, which is hosting the website or the web application that you are testing, and the browser where you are running the test. So they used to work as a bridge or as an interface between server and the browser, which is the client. But now you have web drivers which eliminate these two components and directly work with the browser and also deals with the server directly. So, and you have Selenium Grid. So you can read more about them. So the simplest of the framework is Selenium IDE. This is the test we will do just now. It's like a browser plugin which will record and prepare the test scripts for you in advance, right? It is easy to use and install, right? Has a inbuilt help and test results reporting module. It's not really a huge reporting. It's just just giving a log file to you. For proper reporting, you should have external third-party reporting modules integrated with it. And you can't integrate them with IDE, but you can integrate them with WebDriver and Selenium Grid. So these are the like the more comprehensive testing platform tools that you have there. No programming experience is required, though some knowledge of HTML and DOM. What is your DOM? You know HTML, but what is DOM? Who will tell me what is DOM? Anybody? It's called document object model. Basically, your HTML document actually follows a document object model, which is identified by JavaScript. JavaScript treats everything as a document object, and every element of your website, web page is treated as a document object, and it is given as identifier, a document identifier, DOM identifier, you can call it. And JavaScript can deal or manipulate with those objects using those DOM identifiers, right? So if you have a bit of a knowledge of JavaScript, that is where the DOM identifiers are used. You can use them, right? Allows integration of Java and C# and Python integration. That is more with the WebDriver, not really with the IDE, right? So, and it also allows to export the text scripts in various formats. Again, this is done through WebDriver and Selenium Grid functionality. JMeter can be used as a test performance for static testing and dynamic testing, both. And basically, it works with it works with the Java Java implementations, Java environments like JSP, servlets. These are Java implementations or Java classes, Java server pages we call them, and Ajax. These are again Java implementations. So it works with these programming environments. JMeter can basically test performance by seeing how many concurrent number of users are allowed, and it simulates the number of concurrent users. You can increase the number of users to see how your web application is reacting when you increase the number of users, increase the number of connections, and it provides various graphical analysis for performance reports. So this is just for that. I won't go much into detail, but obviously it tests different things. It helps you to create a test plan, a thread group. It also tests on HTTP requests. It tests on different. It can provide different listeners. It can provide graphs and result trees for you, and that's it basically. So let's quickly go and look at this. How can you install Selenium IDE? The simplest way obviously is that can you still see my screen? Can you see my browser?
No, sir.
Huh?
No, we can only see your slides.
Oh, you still see my slides? Yeah, I was expecting that. So I have to share once I'm opening up this browser again. So here's my browser. Can you see my browser now?
Yes, sir, you can see it.
Okay, so you will be basically going to something called Selenium. Uh, it's called Selenium HQ. Selenium HQ website. So when you click on Selenium HQ website, obviously it is also called Selenium Dev now. I think it has changed. So there is a Selenium HQ and there's Selenium Dev. So any one of them should be fine. And this is a website like seleniumhq.org, right? So this is the site. This is the old initial site, but that doesn't matter. You can click on selenium.dev. So here you are. Obviously, you'll see their opening page. You have to scroll down a bit and look for Selenium IDE. Of course, you'll see that it has Selenium WebDriver. This is now obviously a very powerful tool for creating automated testing for your web applications. You can create automated tests. You can capture and record these tests and you can play them again and again every time you make any change. It supports regression testing tools as well and all that. This is your Selenium IDE, which is a scaled down version, which works as a plugin between your as a Firefox video browser basically. It supports Chrome and Firefox browser. Before earlier last year, it was only supporting Firefox basically when I demonstrated this tool. And then you have a grid. So grid is basically more powerful. It allows you to test distributed application testing as well. So if you have distributed application deployment and you want to scale by distributing and running tests on several machines, which can manage multiple environments from a central point. So your application is distributed across various different servers and is used across different browsers. So you can use Selenium Grid for a distributed and testing of your component based environments as well, right? So this is a brief introduction to that. And obviously, as I said, you would be testing basically, the IDE. So we will go to the IDE, Selenium IDE download. There would be, yeah, I think once you click this, you will be taken to again a set of page. Obviously, it again shows you the same options for Selenium server and everything else. So you'll go to Selenium IDE tab here, right? So Selenium IDE tab, and you'll click on Firefox. So this works very well with Firefox. So you will be probably testing with Firefox. So once you click on this, obviously it will give you option of add to Firefox. Now you saw that button which came there, but now since it's already installed in my browser, it is giving me the option of remove. So I have to remove it and re-add it, which I won't really, I don't feel necessary. All you do is once you open it for the first time, you'll see add to Firefox blue button here, which appeared for a short while before it changed to remove, and you'll just click it. Once you click it, obviously it will add to your browser as a plugin, and it will show up here as a Selenium IDE. A small button or an icon appears on the right top corner of your browser, right? Okay, so this is what I would assume that we have done. So how do you create a testing project? You will click on this Selenium IDE and you'll see this dialog box over here. First thing it will say is record a new test in a new project. So you can open an existing project if you already have it. All you will do is you will click on open and you will browse that existing project. Your projects are normally saved as .side extension, .side. It's basically Selenium IDE. So that is why it looks like side, although we are not taking any sides here. So it's Selenium IDE and it's called as SIDE extension. And you can save your existing projects over here, which can contain multiple test cases. So we won't. So first you would say, OK, record a new test in a new project. OK, you will give a project name. Let's call this project as Amazon testing. You can do testing on some dummy sites which are available thoroughly. Normally, no, it's not really advised to do testing on these commercial sites, but I don't think these commercial sites have time and energy to sue anybody who's doing these kind of testing. But technically, it's not basically recommended. So I'm demonstrating it, but I'm not like recommending it. You can do this testing on your own websites, basically. Yeah, although it's not really penetration testing. It is simply testing the user input and all that. So it's not really like hacking into the system, but legally you should test on a neutral site, on a demo site, not really on a working commercial site. But it doesn't really matter here in this case. So we'll say Amazon testing and you'll click on OK. Now you will give a base URL, of course. To be very precise, you rather open the site. So you open your Amazon.com or .co.za, whichever version you prefer. And if I click on deliver to South Africa, obviously it will show me up as Amazon.co.za. Anyway, it doesn't really matter. So you copy the URL and obviously you would paste it in your IDE. So okay, that's what happens. You at times you have to use your Alt tab in order to move around. Can you still see that dialog box over there?
Yes, so we can't really see Selenium's dialog box.
Okay, you can't. That's always an issue with these screen sharing applications. In this matter, I hate this Zoom and I hate this. Can you see it now?
Yes, sir, I can see it now.
Okay, so what I've done is I've just copied the base URL to this dialog box and I've clicked on start recording. Okay. Right?
Okay.
So once you do that, are you still able to see Amazon opening?
Yes, you see Project Amazon testing.
Okay, you also see Selenium ID is recording, that option there.
Yes, we do.
I'm clicking on all button. Can you see that? And I'm doing a book search. Can you see that as well?
So you can see scrolling in that.
Yeah. So while I'm demonstrating this to you, you can see that it says either I can zoom in, open it in full screen, or I can just keep it like that. Essentially, what is happening, you can see it says Selenium recording. Selenium ID is recording. And if I open up the other window here, you can see, can you see that window as well, Selenium ID window?
You can see the Selenium ID window that has that red button peeping.
Okay, it says mouse out, click, select,
Yes.
click. Okay, so this is your Selenium ID window, and you can see all the actions that you are doing are being recorded over here. So now I actually went and I basically selected a label called books. You can see that the select label is books now. Now I am going there to this IDE and I'm typing books, a name of a book. The Alchemist, by Paulo Coelho. And as I'm searching this book, the book comes up here, right? Again, you would see that the book is here. I can click on this book and see more details about it. I can add this to my cart. At times you will get this message. Do you see a screen there which says, at times it will say that, it's slowing down you get this warning message that you are slowing down the Firefox. The script of this extension Selenium ID is slowing down the Firefox. So obviously you would say either you want to stop it or you want to continue and all that. So you can see that happens sometimes. So whatever you do basically is being recorded. And as you browse between different books, you can see that you can do that. And it is recording all these steps into this Selenium IDE. So as you can see over here, so you would see that I have done a type Alchemist. I have done a search for Alchemist book, and so forth. So you can even go to the shopping cart and process the payment. You can click on add to shopping cart and all that. So as you keep on doing different activities, different actions on the web page, it will keep on recording them as command, right? So these are called Seli commands. These are Selenium commands, and it keeps on recording these actions, and then you can replay them to execute that test to carry on those commands, right? So rather than doing all that manually, you can record one set of actions and they get recorded in your project. You can add different test cases, and that is what you can do. So once you stop the recording over here, stop recording, it sometimes does a little funny thing here. So obviously first I have to stop it here and go there, and then I come here. So please provide the name of the node. So once I've stopped, I see that provide a test name. I'm saying book search. So I've done OK. So you see the project name is Amazon testing and the test case is book search. And I've done a book search and I've recorded this test case over here. So basically the type of command tells you what kind of type of command is, whether it is open, whether it is set window size, you are resizing the window, mouse over, mouse out, all these actions are recorded. Click. So you clicked on a drop down box, so that is recorded. Select. I've selected the label books, so you can see the selected the target is, now this is your DOM. ID, every document object has a ID, and the ID here is search drop down box. This is the name given to a control or an object, whether it is a drop down box, whether it is a text box, whether it is a search field, or whether it is a menu option or a link. Everything is like having an ID, and that is stored in the target. And then you have a value. So value is the label is equal to books. So I selected a label of books, and that's what it records basically. So all I can do is I can play that again. So once I click, and I can have multiple tests created here. You can delete the tests or rename or duplicate or export these tests, right? If you export a test case and you export them to different languages, you see there's a support for Python and Ruby and Java JUnit test or C#. So if you export this, say for example, to a Java JUnit test, you will see that it creates a Java file for you. So this export creates a Java file. You can see the Java extension over here. So book search test.java, and I'm saving it. And if I go and open this, from my documents, I'll see this Java file over here, right? I'm just opening this here in Notepad++, which is just an editor. You can see that it has the whole set of Java file, Java format, and it's a valid Java file. You can see import, JUnit test, JUnit before, after. So it supports the whole JUnit testing framework. And you can see there are public void. Can you see this window? Public class.
So we can't see that.
I'll reshare. And yeah, now you can see.
Yes, you can see.
Yeah, so that is your Java. Yeah, that is your Java file. You can see your public void setup. You can see your public class book search test class file there, which is by default created by the file name. And you can see that the public void book search method is saying that the driver.get is is https www.amazon.com, and then you set the dimensions of the window. Basically, you are resizing the window. Web element object is created, which is picking up everything. Actions, new actions is a driver. You perform a click driver.find element. So everything converts into a Java code which can be tested in JUnit framework, and you can run this test there, right? Web element search Dropbox, web element XPath click. All these are there. Driver.find element, The Alchemist. So I'm searching for this book, The Alchemist. You can see that it's all captured there. So you can create these tests, and this test file can be used in your framework. I can't we can't delve into much of detail, but this is how it is. Similarly, you can export your file to Python format. I would suggest you to do that and see how the Python code, test code looks like. So these are basically, this is your test file for JUnit, which is a Java testing framework, right? And you can see this is how a test file has been created. Now you can add your codes to it. You can change the parameters. You can add loops to it if you want to do a repetitive action, obviously. If you want to test this 100 times, you can run a loop or run something in a loop. So you can do whole lot of programming here. You can create your own programming script completely using this thing, right? You can't do the same thing. I'm just closing this file over here. Can you still see my my Selenium IDE?
No, sir.
Yeah, I know. I hate this sharing arrangement anyway. This is okay. Share again. My goodness. Okay. Yeah. Can you see now?
Yes, sir.
Okay, you can see the ID, right? So you can see here, you can't change anything. This ID restricts you to whatever it has done. You can't add your own code. You can change a few parameters here, like you can change the target, you can change the value, right? That is all you can do, and we'll try and see that, demonstrate that a little bit. So this is how you record all your actions, and you can do that with multiple things. I've already recorded another set of actions on a flight booking site called Travel Start. I'll play that for you. Rather than doing from scratch, obviously you can repeat that step yourself. So you can do that. Now here, if I just play this site, right? Let me do that. And you can see that once I play this, it says preparing for the test run. Can you see that Amazon site is opening? You can see that the books has been selected and the Alchemist has been selected. Can you see that?
So we can only see the Selenium.
No, we cannot see
You
that.
can't see that.
We can only see the Selenium IDE, nothing else.
Okay. Okay. Where is this thing here now? You get such a clutter of these windows. You sort of get lost. Yeah, here I am. Okay, here's the window. Okay. All right. I've got another presentation, M1 presentation coming up now. Nitesh is just, I think, sending me messages, but I still have time here. I think it starts at 3 o'clock. So I think he's just doing some testing. So I would just ignore him for time being. Anyway, are we here? All right. Yeah, we are here, right? Now the thing is, this window opens up in a flash. and then it starts to repeat these steps at a very rapid speed. So it becomes very difficult to, look at that. I'll try and see if I can repeat that. Might be a bit challenging. Okay, I'm clicking the IDE. Can you see the IDE?
So I think you need to share your screen with us and not just the tab. I think you're just sharing this particular web page with us rather than sharing your screen. So when you move from one tab to another, it doesn't show as you're moving to tab. It just shows us that screen only.
Okay. 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 I'm sharing the screen now. Right. Can you see the IDE?
Yes, sir. I can see both now, the browser and IDE.
And the IDE. Excellent. I think that was the issue. I think I wasn't sharing the whole screen. I was sharing different multiple tabs or whatever windows you want to call them. Okay, let's run this again. Can you see the Amazon site opening? Yeah.
Yes, we can see the Amazon site opening.
Okay, so what happened here? If you have noticed, it opened the Amazon site. It went to the filter here which said all, and it went to books, and after books it went to the Alchemist, and as a result of that, it has searched the Alchemist book over there, right? So this is what it has done. It has, in fact, encountered some sort of error after it went to the Alchemist tab here. So I'll come back to the IDE once again, and I'll look at this tab here, right? So this is the tab, okay. And I think at times it does give you some sort of messages. So here I am, and then I think okay, I've encountered an error over here. So you will get some sort of errors. Now I'll go back to this tab, the Alchemist. You can see that I have put up here the Alchemist, and I'll change this to another book. What was that? The car decides to die. Okay, so I've changed this parameter here. The value parameter has been changed, and I would re-execute this test. So here I am, and I will rather run the current test again. So you will see that, okay, it has gone down. It has searched for the books, and it now searching for Veronica decides to die, right? So this is, and it basically searches for that. Probably it didn't take the next click, by the way, but yeah, it should take it. So you can see that you can change certain parameters here, and you can record these kind of actions. If I do another set of tests here quickly, and I'll go from executing to tests, and I'll say pause this test, right? So I've paused the test. This test is now paused, or rather maybe I can stop it. Pause on exceptions, or I'd rather say pause this test. So here there was a error as well. Whenever it takes a lot of time to respond, it might throw an exception or throw an error for you, or it didn't find the thing. Many of the sites are very dynamic sites, so you'll find some problems while you are testing the dynamic sites. Dynamic sites means these sites are not static. Whenever you open the site, they open differently. They will have a different search result. They will have a different list of items being displayed. Probably they'll throw up a pop-up dialog box or something which is obviously created differently at every time. So every time you might find some errors coming up when you're doing this recording. So dynamic sites recording is always challenging, and you may have to do separate set of programming to bypass those errors if you find that they are just hindering your testing process. You can just skip them or sort of like eliminate them, which you can't do, by the way. You can only do, okay, if you have an error over here, so you can only do like step over current command. So you can just step over the current command and go to the next level and see what happens. So the next command is obviously the window size, so it will resize the window. So it does a few things, but this is obviously not the environment for professionals. It is just to learn and get a hang of the environment. It is an IDE. It's not a full-fledged testing framework. A full-fledged testing framework would require you to use WebDriver for a particular browser and a full IDE Selenium environment, which probably integrates with JUnit or with Python programming environments as well. Right. So this is just to demonstrate that probably, yeah, we've done. You can stop the test, stop test execution here. So this is what we have done. You can see that there were a few errors. You can add another test or another project. We can create a new test or a new project. Second time, I would simply do this time by picking up an existing project. So I'll say I'll close it. I can say create a new project, or I can say create a new test. If you want to create new test, obviously that new test case name would be whatever you want to create. You can create another test, which is maybe add to cart, say for example, test. And now this test, obviously, I would say, okay, add to cart test, and I would say run the current test, or I would rather say record here because I haven't recorded anything. So record. Now in record, again, I open up amazon.com. Selenium ID is recording. I will go to all. I will go to computers this time, and I will add desktop computer Dell. Okay. So here I have this, and I'll say this computer, personal computers. Okay. As I delay, automatically I'll see a message will pop in to say, you want to stop this running of this script. I'll say wait. But once it gives a message, it doesn't allow you to continue recording. So you see, there's always a bit of an issue that comes up here. Probably also because I'm not logged in, it will not allow me to add anything to the cart. But you can create multiple test cases. Yes, you can. Yeah, now it has stopped responding, of course. So I have to stop it. Maybe I have to recreate the test, or I have to see what I can do in this test. So this is the add to cart test. If I simply, okay, I have to stop recording as well, right? Now I can execute it. You will see that it will just open up computers, desktop Dell computers, and it will search these desk computers over here, right? So here I am. Now where's my ID? Selenium ID is here. Okay, now I can basically pause here. Has come through anyway. So this is how you can automate the testing. You can run the test. You can change the parameters and execute it many times. That's what basically you can do, right? If I want to open up an existing, open a project, let me open up an existing project which I created in documents. This is travel start test 1, which is already recorded. Open it. Do you sure you want to load new project without saving the current one? I'll say proceed, right? So I don't want to do that. Anyway, so this is a project travel start booking, which has already been recorded. Let's run the current test. So you see I've run the current test here. I've already done searching for like Durban and Johannesburg flight, right? So this is what, and I've searched the dates. So you can see that this information comes up here. Obviously, this is the test which I've already done. And where am I? I'm here. Okay. Here, if I say stop test execution, okay, this test is here. If I say I want to start recording, but start from here, so I can say, record from here. So I'll say record from here. So I can add to existing recording further as well. So you can say it will repeat the existing steps for me. What I did, obviously, I went and I selected Durban and Johannesburg as a flight. I selected the date, so you can see it's already picking that up. And from there, I can do a search. And I'm searching for this flight now. And it has picked up a flight for me from Durban to Johannesburg. And I've got it. This is the cheapest flight. It will ask me to pick the return flight probably from here. So this is the flight which I have got. And okay, there was an error here. As you start waiting, you will get an error. So that's what happens. So I've added a few steps here. If I just want to replay it, you'll see that certain parameters are already here, right? And it's playing that for me. I just want to see whether it goes further from the search field to the next one or not. So here I am. I haven't gone past the search field. Basically, it's probably waiting for some input or throwing some error right at the search field. Here, see here. So I've got an error over here. You can see this is the error I have got here. Select the element Durban. Okay. If I go to the next one, click. Probably somewhere I'll find certain options here. Over here I have an error. If I say step over this and say start recording, okay. And I'll say change, so it's recording change from this to Cape Town. Change the date from 31st of July to 30th July, whatever. And then go and search. So it's recording my click. You can see that the status says Selenium ID is recording this, is recording that. I'll select this as the flight. And obviously I'll select the return flight. And I'll say book this flight. So you can see that it has picked up the flight, the return flight, and now obviously it's saying book the flight. Now it's asking who's traveling. The first name, I'll say the first name obviously is Deepak and the surname is Kumar, and date of birth and all of that is there. So I'll just leave it and I'll say, yeah, Mr. and whatever else. So I leave it at that. I won't go filling up the whole page, and I'll go at the Selenium and I'll obviously say stop recording, right? And now I will obviously play this this test. So you can see that some certain parameters were changed there. We'll see how it performs now. So obviously it has changed from Durban to Cape Town, as you can see. Okay, so this comes in a dynamic way. So obviously I think it didn't really, oh my goodness. So it didn't really pick up that portion, but anyway, if I rerun it, let's try doing that again. So last time I ran it, it ran perfectly fine. This time obviously it's giving me a little bit of issues here. So stop it and then run the current test again. Maybe I'll start to do a full recording, leave it, yeah. I think it will still get stuck on that research. So Durban, Cape Town, okay. Is it passing through from the search to the other one? Something happened there, okay. Selection of some values happened there and it stops right there. Okay. So this is what basically happens. Some parameters sometimes do become an issue, which we have seen rather. Where is my Selenium ID again? Okay, there's my ID. So let me create another test. I'll stop this and I'll create a new test. So here I will simply go to this test. I think I've stopped it. So I'll go to test. I will delete this test and I'll create a new test. Booking, add this test. Start recording. Once again, the site is there. I will increase the size. Okay, search for flights. You can see it has already captured my details, but I think I will still look for flights. I will say one-way flight. There could be a few validations like a person has to be. So it has already picked this up anyway. I'll go to this thing. Basically, it has already picked up that information. So I have to kind of close this window completely and try and say stop this recording and try and do a new run again. But I think still it picks up cookies and it will obviously give me a trouble to do this booking again, because I know it has captured my information in cookies, so it won't allow me to really select these things again. That's the challenge sometimes what happens here. So probably travel start, yes. See, it has already picked this up. And okay, let me click on search. It has already picked it up. Leave it. I won't go in selecting this because that was already demonstrated earlier. Here I have this. Okay, so these are the return flights which has been selected. And I'll say book this flight. Okay, so this is the set of flights I have got here. First name. Walker. I've selected the date arbitrarily. August. Date of birth, okay, whatever it is. Yeah, it doesn't really matter. I think there may be some validations anyway. So this is it, and I'll say total is this thing, and I'll proceed to payments, which I won't really do. So that's it. So you see that contact details, whatever it is, you can add them as well. And from here, I'll go to this and I'll say stop recording, and I'll say just play this recording, right? So maybe I can even say save, and I can say travel start test 2, save it and then execute it. Okay. Okay, so I've selected the flights. Okay, I've gone to the search. See, that is working. It is searching, it is selecting. I've selected the return flight as well. And again, it goes to, the next step. Obviously, now it is entering the names. You can see it is entering the names. Johnny Walker is there. Probably, obviously, that's where I would like it to stop. So I don't want to proceed it too far. I think that's where I've gone. So the names are already filled. Now what I want to do probably is over here. I want to probably pause this execution. And over here, where was that? Adult name. You see the adult name was, last name was Walker. The first name was, the value was obviously entered as Johnny. Now I want to change this value to Junior, or maybe I want to change the value of Walker as well to Runner. I can do that. I can change these values, and I can again execute the test. You will see that the change will be, the parameters or the values that you have changed will be picked up, and you can do a testing with a new value, a new set of values as well. So we went there. We searched the flights. We searched the returning flights. We entered Junior, Runner. You see now the name has changed from Johnny Walker to Junior Runner. So you can see that you can change the values that you are giving in the test, and you can do the test with new set of parameters as well. So that was basically the idea, to demonstrate that it records your testing steps, plus you can change certain values. You can change the object references, the DOM references in the commands, and you can obviously change the parameters which you are supplying as values, right? So that is where it happens. Whenever it stops, it has to wait. There's always a timeout feature. Timeout kicks in and it normally will throw an error. This is basically failed. Implicit wait timed out after 3000 milliseconds, which means 30 seconds. After 30 seconds, if there is no response after 30 seconds, then your session expires. There is a timeout. That happens as a security feature with most of the sites today. So certain security interventions or certain dynamic behavior of the site can still create, a smooth a hindrance to smooth testing of your site using IDE. So that is why the professionals would use the WebDriver environment, and where they can program it, or they can bypass certain steps, and they can control the flow of testing in a more effective manner. So that is basically it from this testing point of view. So we saw the Selenium IDE testing. I would encourage you to try and do a few testing steps yourself after installing this as a plugin. You run some of your tests. Obviously, I demonstrated certain things like how can you save the project, run the project, create different tests. You can create multiple tests. You can delete existing tests, or you can, as you see here, obviously you can create multiple tests and all that. So that's what happens, in these terms. So yeah, so basically this is you can save wherever you want to save your tests with different names, right, with side extension, and that's it. And you can rerun those tests again. So you can automate your testing, and you can record and play it every time you do that, right? So this is it. Thanks very much, guys. I think I'll obviously stop this recording now, and we'll call this the day. The recording will be available once I think I stop recording.